Automated machine learning, AutoML, is revolutionizing the way data scientists and analysts approach model building. By automating the end to end process of applying machine learning to real world problems, AutoML simplifies the workflow, making it accessible to those with limited expertise in the field. This presentation will delve into evaluating an AutoML run, focusing on responsible AI guidelines to ensure ethical and fair outcomes. Evaluating an AutoML run is crucial to ensure that the models generated are not only accurate, but also fair, transparent, and reliable. This involves assessing the performance of the model, understanding its predictions, and ensuring it adheres to responsible AI principles. Proper evaluation helps in identifying any biases, inaccuracies, or ethical concerns that might arise from the model's deployment. The AutoML workflow typically involves data preprocessing, feature engineering, model selection, hyperparameter tuning, and model evaluation. Each of these steps is automated to varying degrees, depending on the platform used. Understanding this workflow is essential for evaluating the outcomes effectively, as it provides insights into how the model was built and what factors influenced its performance. Data preprocessing is a critical step in the AutoML workflow. It involves cleaning the data, handling missing values, encoding categorical variables, and normalizing numerical features. Proper preprocessing ensures that the data fed into the model is of high quality, which directly impacts the model's performance. Evaluating this step involves checking for any pre-processing errors or biases introduced during this phase. Feature engineering and selection are automated in AutoML to identify the most relevant features that contribute to the model's predictions. This step can significantly impact the model's accuracy and interpretability. Evaluating this involves understanding which features were selected, how they were transformed, and ensuring that no important features were overlooked or irrelevant features included. AutoML platforms often evaluate multiple algorithms to identify the best performing model for a given dataset. This includes training various models and comparing their performance based on predefined metrics. Evaluating this step involves understanding the criteria used for model selection, the performance metrics considered, and ensuring that the chosen model aligns with the problem's requirements. Hyperparameter tuning is the process of optimizing the parameters that govern the training process of a model. AutoML automates this by testing various combinations to find the optimal settings. Evaluating this step involves checking the range of hyperparameters tested, the method used for optimization, and ensuring that the tuning process did not overfit the model to the training data. Model evaluation metrics are crucial for assessing the performance of the model. Common metrics include accuracy, precision, recall, F1 score, and AUC ROC. Evaluating an AutoML run involves analyzing these metrics to ensure the model meets the desired performance standards. It also involves comparing these metrics across different models to select the best one. Interpreting model predictions is essential for understanding how the model makes decisions. This involves analyzing feature importance, partial dependence plots, and SHAP values. Evaluating this step ensures that the model's predictions are transparent and interpretable, which is crucial for building trust and ensuring the model's decisions can be explained to stakeholders. Responsible AI guidelines are a set of principles designed to ensure that AI systems are fair, transparent, accountable, and ethical. These guidelines include fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. Evaluating an AutoML run involves ensuring that the model adheres to these principles to prevent any unintended harm or bias. Fairness in AI involves ensuring that the model's predictions do not favor or discriminate against any group. Bias detection techniques such as disparate impact analysis and fairness metrics are used to identify and mitigate biases. Evaluating this step involves checking for any biases in the model's predictions and taking corrective actions to ensure fairness. Transparency and explainability are crucial for building trust in AI systems. This involves making the model's workings understandable to stakeholders and ensuring that its decisions can be explained. Evaluating this step involves using tools like LIME or SHAPE to provide insights into the model's decision-making process and ensuring that these explanations are clear and accurate. Accountability in AI involves ensuring that there are mechanisms in place to take responsibility for the model's outcomes. This includes having clear documentation, audit trails, and governance frameworks. Evaluating this step involves checking that these mechanisms are in place and that there is a clear process for addressing any issues that arise from the model's deployment. Privacy and security are paramount in AI systems to protect sensitive data. This involves implementing measures to ensure data privacy, such as anonymization and encryption, and securing the model against potential threats. Evaluating this step involves checking that these measures are in place and that the model complies with relevant data protection regulations. Inclusiveness in AI involves ensuring that the model is accessible and beneficial to all users, regardless of their background or abilities. This includes considering diverse user needs and ensuring that the model does not exclude any group. Evaluating this step involves checking that the model is inclusive and that its benefits are equitably distributed. Continuous monitoring and improvement are essential for maintaining the performance and fairness of AI models. This involves regularly checking the model's performance, retraining it with new data, and updating it to address any issues. Evaluating this step involves setting up monitoring systems and processes to ensure the model remains effective and fair over time. To illustrate the evaluation of an AutoML run, let's consider a case study in healthcare. An AutoML model is developed to predict patient readmissions. Evaluating this model involves checking its accuracy, ensuring it does not introduce biases against any patient group, and making sure its predictions are interpretable by healthcare professionals. This case study highlights the importance of responsible AI guidelines in real-world applications. In conclusion, evaluating an AutoML run involves a comprehensive assessment of the model's performance, fairness, transparency, and adherence to responsible AI guidelines. Best practices include thorough testing, regular monitoring, and continuous improvement to ensure the model remains effective and ethical. By following these practices, organizations can leverage AutoML to build reliable and responsible AI systems.